Let's have better idea on how to sketch cosine functions. Refer to example 1, where we have fx equals to 5 cos bracket x plus pi over 3. So first of all, I would like to identify where is the initial point of our graph starts. So we start with the calculation of phase shift using mx plus c equals 0, where we take the bracket terms here, we make it equal to 0. So we have the answer x equals to negative pi over 3, where the cycle of the graph, I will have it begin with x equals to negative pi over 3 later. Then next, we would like to calculate what is the period for these functions here, where the calculation is by the formula 2 pi over modulus m, where the m is referred to the coefficient of x here. So as a result, I have 2 pi over modulus 1, so the answer is 2 pi. So one cycle of the graph will complete in the length of 2 pi. Next, using this period here, we would like to find out what is the subinterval width by having the period divided by 4. And as a result, I have 2 pi divided by 4, pi over 2. And this value that we obtain is actually the common difference value that we're going to use for constructions of the table for graph sketching later. So let's see. In here, we will construct a table with the column of x and fx, where the corresponding to the x value and also the fx in the function. And this table here is meant for the case of one cycle, where we have 5 values here, 5 pair of values here, where the first one, we will begin with the phase shift value, which is negative pi over 3. The next x value I have is that we add on with this common difference that we find out from the subinterval width. So with plus pi over 2 on it, I will have pi over 6. Further, plus pi over 2, plus pi over 2, plus pi over 2. So these are the x value that I have for the case of one cycle here. And now we continue with finding the corresponding fx value accordingly. And we have the answer 5, 0, negative 5, 0, 5. So once this table is completed, the next thing what we're going to do is that we go on with the graph, where we begin with the x-axis, and let us insert all this info of x here accordingly. So we insert negative pi over 3, pi over 6, 2 pi over 3, 7 pi over 6, and then 5 pi over 3. After I insert the x value, next I would like to insert the y-axis and the corresponding value that I need from the fx, which give me, I have the y-axis come with the value 5 and also negative 5. And this intersection point here is actually for the case of y equals 0, because I have limited space, that's why it's not displayed here like the 0. Next, what we're going to do is that let us plot each pair of this point here on the graph, and then we construct the graph. So the first pair, I have negative pi over 3 and 5. Next one, I have pi over 6, 0. Followed by, I have 2 pi over 3, negative 5. 7 pi over 6, 0. 5 pi over 3, 5. So these are the points that I have. The next thing I will do now is that let us complete the graph by connecting the point accordingly. So this is the graph that I have, and let us erase the unnecessary trace of the plotting. By right, it's a graph sketching, so we shall not show the plotting so obvious there. So therefore, this is the graph for one cycle. And this is the foundation for us to determine how the graph looks like for a given domain later. Next, if let's say the questions now, instead of having the graph for one cycle, where one cycle doesn't fulfill the domain given, if let's say the domain now I want to have is that for the general case, infinity to infinity. So by right, if this is the framework that I have for the coordinate axis, for infinity to infinity, the coverage will be the full graph, the full x-axis, as I highlighted in green in this diagram here. Then in that case, what we're going to do is that we need to extend our graph, and before that, let us extend the x value towards the left, towards the right and towards the left. So towards the right, we will plus the common difference value that we found just now. Towards the right, we will minus the common difference value that we find just now. So as a result, we have the answer, the next one. By right, we plus the common different value. We will have it plus with pi over 2. So plus pi over 2 on 5 pi over 3 plus pi over 2. The other side, we start to minus pi over 2, minus pi over 2, minus pi over 2. And once this frame is ready, we can extend our graph accordingly. So we extend towards the right hand side, we extend towards the left hand side to get the answer. So by right, this is the shape of the graph that I have for the case infinity to infinity. Of course, if I extend the x-axis, the graph will continue extend accordingly. But this is the framework that I have, so I just draw until like this form here. And next, what if let's say now I have the case that I would like to have the graph in the domain of 0 until 2 pi. So what I'm going to do here is that let us identify where is the coverage for 0 until 2 pi. And let's see, we have the x value here from negative pi over 3 until 5 pi over 3. We found that this part here we have exceed the domain, and the other side here is less than the corresponding domain. So what I need to do now is let us find out where is the value of 2 pi. By referring to this value here, 5 pi over 3 is very close to 2 pi, and I suppose 2 pi is somewhere near here, and therefore this is the coverage that I should have for this domain here. And I realize this part here is happen to be excessive. Later we're going to erase it, and the other side here, it seems like I need to extend a little bit more. So therefore, let us now complete the graph by erasing this excess part and extend this part that is insufficient. So there goes the answer for the case from 0 to 2 pi.